Okay, I wanted to make a video to show the shape of the Earth. Is it a simulation? What is a simulation? And basically I'll just try and explain how a simulation works. For an example, this guy here, if you were seeing through his eyes through the simulation and he was walking in the simulation, he's not actually moving. The ground is moving underneath him. Okay, you can see that he's always in front of the screen by a meter and the ground is always moving, and that's how a simulation works, is that the ground moves, not the person. So if I was this person in the simulation, I would feel like I'm actually moving. That's me walking rather than the ground moving. It's the same when you have a car or a plane. This is in a plane. I'm watching a simulation of a plane. Okay, well, the ground is actually moving, not the plane itself. The ground is coming underneath the plane. But if I was in this simulation, I would think I'm actually moving. I'd feel like I'm actually flying. It's just how a simulation works. It's the same with a car. If I'm in a car, for an example, watching the simulation from outside the simulation, the car isn't moving, the ground is moving. Well, this is a real life footage of someone driving a car. Well, the thing is, if I was in this car driving it, I would feel like I'm driving it due to the senses that I have and how I experience things inside the simulation. It's like programming this guy in the car to have feelings and senses and emotions and he feels like he's actually real, where in fact he's just programmed to feel like he's real. You could program this guy that's in this car to build the car, build an aeroplane, build anything. You can program him to do that, and he will think that he's invented a car and built a car, and the thing is, he's just been programmed to build that car. The same with watching this. If I was playing this as a game, I would just be playing it as a game and thinking that I'm driving the car, but I'm not in fact actually moving anywhere. The ground is moving underneath me, but because I'm inside that simulation, it feels like it's real. It feels like you're moving along the ground. Sorry, the battery went flat. But yeah, even in this simulation, if this guy runs 1,000,000 miles in this simulation, it's nothing but a calculation. He hasn't run anywhere. He can run as far as he likes. He's still in the same location. The ground is moving. If this was me in the simulation, I'd feel like I've ran 1,000,000 miles, but in theory the ground has moved 1,000,000 miles. And that's basically how the Earth works. That's my theory on how the Earth works. Even this guy in the simulation, he's in the same location as this guy. He's basically exactly the same. He's just moving relative to me in his simulation. He's in the same simulation. But yeah, even though you can drive 1,000,000 miles, it's just a calculation in the simulation. But yeah, anyway, I'll get on with showing you how the Earth, my theory on how the Earth works in a simulation. Okay, this is how a simulation works. You're on the outside of the simulation, I'm on the inside of the simulation. And basically, when I walk around, does it feel like your camera screen is moving, or does it look like the ground is moving within the camera screen? The screen that you're watching, it just looks like everything is moving within the screen. Your computer screen isn't moving. It's only that I'm in the simulation and I feel the senses and the motions and the every little electrical signal to feel, and I think that I'm actually moving when in reality you're just watching me through a computer screen. That's how a simulation works. Okay, this is how I believe the Earth works in a simulation. There's my my model of Earth. So basically, everyone is along this center line, which is your north to south, which is negative to positive, which is the electronic field within Earth. This is where all the signals come in to Earth for the simulation. For an example, if I'm in Australia, well, for an example, the sun. When the sun moves around the Earth is moving under the sun. So basically the sun, this is at the equinox. So the sun itself has an angle from the sun to the north to the South Pole. That's where the light exceeds its limit. It can't light up any further. When the Earth is spinning, or when the sun is actually going around the Earth seems like it is moving under the sun. Okay, it's the same with if I want to go to Australia. I'm in Australia. Okay, this is me in Australia, and I want to go to America. I'm basically traveling around the Earth. The ground is moving underneath me. Okay, and now I'm in America, but my parents are still in Australia relative to me. Well, the people in Australia are in the same location in Australia, and I'm here relative to them. If you understand that, in a simulation, that's how it can work, because we're all down this same line. This same line can make you think that you're on a ball. But this is basically demonstrating how the equinox works. The sun is in the center. For an example, if you have two of these, this is your equinox line. This is the summer in the south. This is the summer in the north. Okay, and if you spin these down that equinox line, that's why the sun is going down that straight line. And that's why if you spin these around together and they all join up, what happens is you make the exact same map as what the Google Maps makes. It makes our exact map. Which is this map. That's what it actually makes. You have the North and South Pole. Okay. How the sun actually works for seasons. The sun and the moon actually goes from the Tropic of Capricorn, Cancer, all the way up to Tropic of Capricorn, and comes all the way back within 1 month. And what happens is when this is spinning around, that moon is slowly going up. This is the sun spinning around the 23-degree latitude, okay, and it's lining up with South America. It goes over Australia, it goes over Africa, goes over South America, back around to Australia. And the same with how I showed in my time zones. Oh. What was that under? But that's basically how it works. And when the sun and the moon, they do the same speed, and when that goes up here, basically what is happening, here is my other diagram. Pen underneath it. When I'm in Australia, okay, the sun, you can see my sun, the little, let's see if I can zoom in on it, the little yellow ball, okay. Australia is down the magnetic line, but what's happening relative to me is the sun looks like it's moving around. Okay, you understand that? Another thing is temperatures. When the sun is over Australia, you have cold this side. Basically, the sun shines. Oh, I'll zoom that back out so you can see. When the sun is basically over 23 degrees south, the sun shines to the other side of Antarctica, which is this circle line, and it shines to this starting line. So if I spin this around, the sun is always going to be shining to here and to here, all over Earth. Okay, that nail was not hammered in properly. But what that does is the temperature up in the north is freezing cold, okay, because the sun is so far away from the north. It's over the top of 23 degrees south, so everything in the south is hot, apart from the distance from the sun to Antarctica. That's why you have this cold area around here, and the same with why you have the cold area around here. Well, when it changes seasons, this sun comes slowly towards the equinox, and then you'll find you'll get a hot area over the equinox. It starts to get colder here, and it's starting to warm up here. By the time this sun moves to here, now you have a hot temperature here, and you have a colder temperature here. This explains the temperatures. A sun that's 93 million miles away on a ball, for an example, this is the equator line. A sun over 23 degrees, okay, is going to warm up this area at around 30 degrees. The further you go this way, 20 degrees, 10 degrees, freezing. Then when this sun goes back over the equator, you're getting average 30 degrees here, back to 20, back to 10, 20, 10. By the time the sun's back over 23 degrees north, then you're getting your temperatures again back up to 30, sometimes 40 degrees, because the sun is over your head. It's not a million miles away. And when the sun is over the equator and it shines to the South Pole and to the North Pole, like how the diagram is, what do you think that represents? This is your south, this is your north, and the sun is at the equator. What does that look like? Nothing conspiracy at all. But anyway, but yeah, that basically shows how my equinox works. It's the same with the stars. If you're in Australia, the stars are spinning around on the top. So basically, if you point your telescope with the polar axis to the center, it's doing exactly what it is on the bottom of a ball. It's tracking the circles around the pole star. And another thing is perspective. I've actually made a video demonstrating that you can actually measure the angle of perspective, and that's basically how you see things. Things actually bend down. It's a proven fact. You can actually measure it, mathematically measure the angle of perspective. When things get further away from you, they go down. And that's how things works, like how a hallway works. But that's my demonstration on how a flat earth can work in a computer simulation. Thanks for watching.